Okay, let's take some more examples for the complement of the DFA. Let's say that there is a DFA L. Let's say there's a language L which is W such that W starts with A. W such that W starts with A. W starts with A. Summation is equal to A comma B. So it is clear what should be W dash. What should be W dash? What should be L dash? The L dash should be W such that W does not start with A. W does not start with A. Okay, and summation is equal to A comma B. It's clear. Now this is DFA. It is very much it is very self-evident that L and L dash are complement to each other. Okay, let me make it L1 and this is L2. Let's say this is L2. So we know that L1 and L2 are complement. L1 and L2 are complement, and we can give DFA easily for both of them. So let's try to directly construct DFA for L1. Okay, let's say this is M1 is equal to let's say M1 is L1 for L1. Let's say we are constructing DFA which is M1. So Q0 it is should start with a string is starting with A. Now you have to accept this. This is Q1. Anything that comes now you have to accept it. At Q0 if you see B, then you should go to a state which is a dead state. Let's say this is Q2, and now this is what the DFA for L1 is. Similarly, what would be the DFA for L2 and M2 if you want to give it directly? Okay, one more thing. Whenever you draw DFA, try to draw minimal DFA at the first go. Okay, so Q0 if it starts with A and it says does not start with B. So if it starts with A, it means this Q1 has to be non-final. And it has to be a dead state. If it starts with A, it has to be dead state. It does not start with A. It means that if it starts with B, it's clear the string has not started with A. So whatever comes afterwards, I don't care. This is going to be a final state. So if you see the difference between the two M1 and M2, it's just the differences in the final states. Everything else is same. Transitions are same. Okay, so the difference is in the final states. In case of M1, the final states are Q1. Final state is Q1. In case of M2, the final state is Q2. Okay, that's what it is. Similarly, if you look at another example, let's say L1 is omega such that length of omega is equal to 0 mod 2. 0 mod 2. So you know that it's mod 2. So when you have something like as mod n, then in your DFA is going to be how many states? It's going to be n minus 1 state. DFA is going to be n minus 1 state, with each state referring as 0 mod 2, 0 mod n, with each state referring as 0 mod n, 1 mod n, 2 mod n, so on, n minus 1 mod n. We have seen all these things. So it is 0 mod 2, it means there's going to be 2 states. One state will be representing the strings that corresponds to 0 mod 2, and another string will represent the string, all those strings that will correspond to 1 mod 2, means all those strings that will end up at Q1. All those strings, the length of all those strings is going to be not a multiple of 2, and 0 mod 2 is the length is going to be even. So this is what any string, if from you are at Q0, if you see any symbol you go to Q1. Similarly, when you are at Q1, if you see any symbol you come to Q0, and Q0 is the final state. So this is L1. What is the complement of L1? The complement of L1, L1 dash, is equal to omega such that mod omega is not equal to 0 mod 2. It is same as saying omega such that the length of omega is equal to 1 mod. So how do you give the DFA for this? You will have Q0. If you see any symbol, you go to Q1. Similarly, when you are at Q1, you see any symbol, you come back to Q0, and Q1 is the final state. You can see the final state in case of M1. If this is M1 and if this is M1 dash, of course this will be M1 dash. So if final state is Q0 and here the final state is Q1. Just in case, in the last video also we have seen that in this case we can easily give DFA for the both languages. But if you can give a DFA easily for one language, then what you have to do to find the DFA for its complement? Just make the final as non-final and non-final as final. Rest everything is same. All transitions are same, all states are there. Okay. So it's clear here. If L is a regular language and M is DFA such that L of M is equal to N, then L dash is also a regular language and DFA for L dash can be obtained from N by making the final state of M as non-final and non-final state of M as final. How can you represent it? Let's say if M is a DFA, let's say if M is okay, I have not explained the mathematical definition of DFA, but still okay. But still look at this. So if this is your M, okay, if this is your M, okay, 1 minute. So if this is your M, so what is Q? Q is set of states in M. Set of states in M. And F is set of final states in M. Set of final states in M. Then what is M dash? What would be in M dash? The set of states would be Q. Same. The set of states would be Q. And what is the set of states in here? The set of states here would be Q minus F. Okay. And what about the transitions? The transitions would be same. Transitions would be same in M and M dash. Listen, I am explaining the theory. When you practice problems, if you are looking to give entrance exam, you have to enroll in some tests. Let's take another example. L1 is omega such that every A should be followed by a B. Every A should be followed by a B. So if you have every A should be followed by a B. So when you are at Q0 initial state, if you see a A, so you go to Q1, the next symbol should be B. You go to Q2. Okay. So when you are at Q0, if you see a A, okay, when you are at Q0, if you see a B, you stay at Q0. But the moment you see a A, the next symbol must be B. And then you make Q2 as the final state. You have to make Q0 also as the final state. Right? Because the condition is not that you have to see A. But if you have seen A, the next symbol should be B. If A is there in the string, the next symbol in the string should be B. If so the language contains epsilon, the language contains simple b, or the language contains any number of b's, right? And if you see a, then there has to be b. So that is accommodated with these two transitions. Now when you are at Q1, if you see a, when you are at Q1, it means we have seen one a, and next symbol is a, it means a is not followed by b, then they should go to a steady state. So at Q1, if you see a, you go to a steady state. Let's say that is Q3, and this is a steady state, a comma b. Similarly, when you are at Q2, if you see any number of b, you can stay at Q2. But if you see a b, if you see a at Q2, then you should go back to Q1. Okay, so this is the DFA for L1. This is the DFA for L1. Let's say I ask you, what is the DFA for L2? Let me define what is L2 is. What L2 is. So L2 is W. What is this? Every A should be followed by B. What I make L2 to be? Every A should not be followed by B. Should not be followed by B. I should make must not be. Must not be. That would be more correct. Every A must not be followed by B. Okay. So what is the DFA for it? What is the DFA for it? From the looks of it, you can think that L1 and L2 are complement to each other. It may appear that L1 and L2 are complement of each other. Right or not? If L1 and L2 are complement, what does it mean? It means L1 is equal to summation star minus L2, or L2 is equal to summation star minus L1. But that is not the case here. Because L1 contains epsilon, contains B, any number of B. If it sees A, next symbol must be B. This thing has to be there. But apart from that, if it sees any number of, apart from that, let's say, if it sees any number of B, B star, AB, B star, that is L1. This is L1. We have not studied regular expression thoroughly, but the amount that we have discussed, you should get it. This is L1. That if you get any number of B in the beginning of a string, it does not matter to you. The moment you get a, the next symbol should be B, and then you can get any number of B. It does not matter, you will accept it as string. Similarly, then what is going to be L2? It will accept epsilon, it will accept B, it will accept any number of B. But if you get A, the next symbol has to be A. And then you can get B, it does not matter. So if you get A, the next symbol has to be A. So L2 is something like this, B star, but if you get A, the next symbol has to be A, and then you can get any B, it does not matter. So there are many strings that are common in L1 and L2, that is L1 intersection L2 is not equal to 5. L1 intersection L2 is not equal to 5. Okay, and you will see this while you, okay, let me construct a DFA for L2 directly now. So what should be the DFA for L2? What is L2? Omega such that A must not be followed by B. A must not be followed by B. Then this is Q0. Any number of B comes. We are not checking anything. We stay at Q0, and Q0 is also a final state. If you see a, the next symbol should also be a A. But if the next symbol is B, then you go to a dead state. And when you are at Q2, if you see any number of B, you stay there. And if you see another A, then you go back to Q1. So this is what the DFA for L2 is. Just look at the DFA for L1 and L2. Look at the DFA for L1 and L2. From Q1 to Q3, you have a transition when you see A. From Q1 to Q3, you have a transition when you see B. So transitions are not same. The final states Q0, Q2, the final states are same. So L2 is not a DFA that is obtained by changing the L2 is a minimal DFA, L1 is minimal let's say if it is M2, and this is M1. M1 and M2 are minimal DFA, and M2 is not obtained from M1 and rightfully so, because L2 is not a complement of L1. Okay, so this is it. That's it. So what I would suggest is that when you are given a question about the languages, most likely if you can construct a DFA by itself, just do it. But if you cannot construct a DFA, then just be careful if it is really a complement of the language or not, or just it is appearing to be a complement and it's actually not a complement. So that is what you have to be careful. And here we will end this topic of the complement of a language, the DFA and the DFA of the complement of language, if the DFA for the language is known.